students. Welcome to the course Natural Language Processing. My name is Priyanka Gupta. I am working as Assistant Professor in Department of Computer Science and Engineering, Data Science Department at Institute of Aeronautical Engineering, Hyderabad. Today I am going to discuss about n-grams in natural language processing. So I am going to discuss about what is actually n-grams are, how many categories are there, how to identify n-grams, what are the how n-grams will be used for NLP tasks, and what are the applications and limitations of this n-grams are there. And I'll also discuss about the how to make a n-gram language model. So that will be used as an NLP model. So how to make that and what is the procedure. What are n-grams? So actually an n-gram is an contiguous sequence of n words. So means if we are having a document, a paragraph, so where we by this applying this n-gram, we need to make tokens combining one word, combining two words, or combining more than one word, n words. So that is why it is called as an n-gram. So for example, if let's say espresso shots. So these are two words. So that is a 2 gram. That is a 2 gram. A medium blog post. So that is having the 1, 2, 3 and 4 words. So whatever letter word is just separating by the white space in English language, that is called as a one word. So here 4 words are there, right? So that is called as that will be called as a 4 gram. Likewise, that right on medium, that is again a sentence. So here 3 words are there, so that is a 3 gram or trigram. So the n-grams, these can be letters, words, or base pairs according to the application rules. The n-grams typically will be collected from a text, a speech. So it can be a speech corpus, either it can be a text corpus. So a long text dataset can also have these paragraphs and document. N-grams of text are extensively used in text mining and natural language processing tasks. So whenever we are taking a NLP task, there most probably we are using the n-grams to just segregate the different words, a combination of words. So they are basically a set of co-occurring words within a given window. And when that is going to compute the n-grams, we are going typically move one word forward. So although we can move X word forward in more advanced scenarios, either one word, 2 word, 3 word or n words. So for example, for the sentence, the cow jumps over the moon, there is a sentence, right? So here if I need to identify how many grams are there, so if I will just set n is equal to 2, that is known as a bigram. So how many n-grams, how many bigrams can be possible? So let's see. There can be the combination of the cow jumps over the and the moon. So there can be the 5 n-grams there in this particular sentence where we are combining a bigram. So yeah, here we are having the 5 n-gram in this case. So let's consider, notice here in this, when we are moving forward from the to cow, when we are moving there was a sentence, the cow jumps over the moon. That was the sentence. Okay. So whenever we are moving forward from this way, from the to cow and cow to jump, and again from jump to over, so essentially moving one word forward to generate the next bigram. So here we are making one bigram, here we are again making second bigrams, here again we are making third bigrams, so on. So that is how, if I will talk about n is equal to 3, if I'm combining the trigrams or 3 grams here, so how many words can be occur here? Let's see in this particular same sentence, right? The cow jumps over the moon. So if I am taking the n is equal to 3, that is trigram or 3 gram. So how many combination can be there? How many n-grams can be extracted? So the cow jumps, there can be the 1, okay, 1 trigram. Cow jumps over, that is second, that again jumps over the third and over the moon. So there can be the maximum 4 n-grams possible in this particular sentence, right? So when n is equal to 1, this is the refer to a unigram. So here we have taken the bigram and trigram examples. So this is going to be individually taking the words from the sentence, right? And that is making a n-gram. When n is equal to 2, that is called as a bigram, and whenever n is equal to 3, that is called as a trigram. When we are having the n less than 3, that is usually going to referred as 4 gram. If that is n is more than 3, n is greater than 3, that is going to referred as, that is having the 4 grams or 5 grams or so on. So let's see example here in this figure, that is an n-gram example. So if we suppose we are taking a sentence, this is a sentence, right? So this is a sentence that is going to refer as a unigram. This is a sentence. There are 3 n-grams are there, that is a combination of bigrams. Here again, this is a and is a sentence. So there are two possible n-grams are there. Here are 3 possible. Here are 4 possible, right? So likewise that we have to identify how many n-grams are there. So what are n-grams used for? When we will use these n-grams? So n-grams are used for actually for a variety of different tasks in natural language processing. For example, when we are developing a language model, n-grams will be used to develop not just a unigram model, but it also can be bigram model, it can also be the trigram and so on. So whenever we are applying a language model, we can use the n-grams to just make a combination of word, just identify what is the next word can be there, right? So that we will discuss in the language n-gram language model, but that is the thing we are going to do in this task when we are applying the language model having the n-grams. Google and Microsoft have developed the web scale n-grams models that is going to be used in variety of tasks such as spelling correction, word breaking, text summarization. So in these few tasks, the n-grams is going to be help us to identify the different combination of words together, extracting some letters, extracting some we can say spellings together, right? So using this n-grams, these few tasks can be possible. So Google and Microsoft has done that. They have just applied this n-gram language model, and they have just extracted different spellings, we can say words, when they need to break it, when they need to text summarize the different text. So they done that in the web search Google. Now here are some publicly available web scale n-gram models are there, that is by the Microsoft. So this is a link. By just clicking on this link, we will have the different available n-gram models that some people have applied, and this Microsoft also has applied in their particular applications. So here is a paper also there that is going to use web n-gram model for text summarization. So that has been used by the micro opinion generation and unsupervised approach for generating ultra concise summaries of opinions at one place. So basically that is having this link is there. So whenever we will click on that link, that is having the opinion from the different peoples, and how it has been summarized at one place using this n-gram model. Another use of this n-grams can be for developing features for supervised machine learning models, that is SVM, MaxNet models, and NAPES. So in this so another use of this n-gram can be there in the possible machine learning models, like they are going to develop some features from the supervised machine learning. So that can be the support vector machine, MaxNet models, and name-based models. So there it has been applied. The idea is to take the to keep these tokens such as bigrams, unigrams, and grams, other grams, in the feature space instead of just unigram. So that is how the tokens can be separated. Applications of n-gram model in NLP. Let's discuss. So n-gram actually having the wide variety of use that we have seen in the last slide also, that we can do the text summarization, we can do the we can spelling correction, we can also do the whenever we need to just identify some tokens there. So some applications of n-grams in NLP can include the auto completion of sentences, auto spelling check, we can say semantic analysis. So they are also used in the DNA sequencing, other computational linguistic applications also. Let's see so few applications that is going to be widely used. So one of them are speech recognition. In speech recognition, the n-gram language model is going to use how it is going to predict the next word. It is going to predict the next word in a spoken sentence, and that is going to give the most possible next upcoming sentence by this using this n-gram language model. So this helps. This is going to help us also to improve the accuracy of that particular transcription of particular sentence, a paragraph, right? So that is the use of speech recognition having the n-gram model. Next application can be the machine translation. In machine translation, actually the n-gram models that is going to predict most likely translation. So for a particular word, if we are going to give one particular word, what can be the possible next translation for that? So that model is going to give that by the sentence based on its context. So the model is going to identify the context of the particular paragraph of a document, and then whenever we are searching for a particular word, that is going to give the most possible translation of that, right? The next application can be there, that is text classification. In text classification, the n-gram model is going to use to classify a text document into the different categories. So that is going to just identify the different categories, a genre, we can say a variety from the particular document, or number of documents, and then it is going to just segregate that. So that is the use of this particular text classification, but that also the model is going to identify based on the content of the particular document. That is going to identify according to content, and that is also in the category that is going to segregate. The next possible application can be there, the information retrieval, right? Sentiment analysis. In information retrieval, the n-gram language model is used to rank the search result, right? That this type of retrieval can be possible if we have seen this Google search, right? If we have seen the Google Scholar, so where we are using some keywords, sentence that is going to give the most possible, most ranked document at the first, and then in the order, right? Based on the relevance of the particular query, what we have typed there, what we have written there. So that is how it is going to retrieve the particular information, a relevant information in the form of information in order, in the rank. Limitations of this n-gram language model can be there in the NLP. The n-gram language model has also some limitations. There is a problem with the out of vocabulary words. So sometimes the model can have the lack of some this vocabulary out of their dictionary, out of their storage. So these words are during the testing, but not in the training. So whenever we are going to give the training words, we need to give the some training, we can say document training words of sentences, and then we can just test that, right? That is a machine learning model. So here, because of the training we have given, but that can be possible whenever we are giving the new words, new tasks, that is not going to identify, not going to give the particular result because of the having the lack of the vocabulary. So one solution is to use the fixed vocabulary can be, we are going to convert out the vocabulary words in the training to the pseudo words. So whenever we are having the words that cannot be identified by the language model, that we are going to fix that particular pseudo word as a vocabulary there in the particular model in the training set. So when we implemented in the sentiment analysis, the bigrams models can outperform. That is going to perform out of the model for the unigram model, but the number of the features is then going to be double. So in these type of in these type of tasks also, it is possible the unigram can be a number of, but it is going to be have the maximum to maximum in the training set whenever we are going to just work on the sentiment analysis. So the scaling of these n-gram language models to the larger data sets are moving to the higher order needs better feature scaling, feature selection approach. So that to just fix this these type of problems, we can just do this feature selection process. We can use this feature selection process to just get rid of this problem that is going to occur in the sentiment analysis. That can be the solution for that. The n-gram model that is going to capture the long distance context poorly. So whenever that word or sentence, a particular we can say word is going to be identified and that is having the much distance from each other, that is also on the context, that is some of the times it is not possible to do correct, do give the right we can say words together. So it has been shown after every 6 grams the gain of performance can be limited. So maximum to maximum, whenever we are applying the n-gram language model, it can work up to the 6 n-grams. That is also we should actually use till 5 n-grams model. So that can be best for us to just implement. N-gram language model suffers from the sparsity problem sometimes, where some of the n-grams may be not occur in the training curve. So that is same as it is whenever we are having the lack of the vocabulary, whenever we are having the we can say lack of the some training data, so that is going to give the 0 probability to give the resultant words or sentence or letter out of this language model. So this problem is going to be addressed using the smoothing techniques, right? So by using these smoothing techniques like Laplace smoothing and good Turing smoothing technique, we are going to just solve this problem also. That is sparsity problem we are going to just remove. So like that, the limitation can be also possible to just get the solution to apply some other type of techniques on that. N-gram language model assume that the probability of word depends on its previous n-1 words. So which is not always true in real world scenario. It is not possible whenever we are applying this model on the real time scenario applications. So in that, n-gram language model does not capture the semantic meaning of the words, and sometimes it cannot handle the ambiguity also. So these are the few limitations can be there, and we can also solve this by applying the different techniques, right? So these are the different limitations in that particular n-gram language model. Now we will discuss what is actually n-gram language model is, how to just implement that, how to just make that. So n-gram actually may be used to create probabilistic language model, that is n-gram model. N-gram model is going to predict the occurrence of a word based on its n-1 previous word. Means whenever we are just going to, whenever the model is going to identify the next word, and based on the previous word, it is going to give the probable output out of that, probable occurrence of that. So the n-gram language model predicts the probability of a given n-gram within any sequence of words in the language. A good n-gram model can going to predict the next word in the sentence, that is a value of p of word of h. For example, n-grams such as unigrams, that suppose one sentence is there, this article is on NLP. This article is on NLP. So how many unigrams can be there? There can be the each and every word is a unigram. So this article is on NLP. So there are 5 n-grams there, and based on unigram, based on n number. If I just discuss about bigram, so this article is 1 n-gram, article is second, and is on third, and on NLP is fourth. So there are 4 n-grams are there, depend on the bigram, combination of 2 words. Now we will establish a relation on how to find the next word in the sentence using probability of W on H. W on H. So we need to calculate a probability of W on H, where is the candidate for the next word, that is for the next word identification. So let's consider we want to calculate that what is the probability of the last word being NLP there given in the previous word. So for that let's suppose probability of NLP of on this article is on. This article is on. So we need to identify NLP from that particular word, but the previous word is there, the previous word from the sentence is this article is on. So that is the previous word. So we need to identify the probability of NLP on this article is on. After generalizing, the above equation can be calculated as probability of W means word 5 that has been on W1, W2, W3 and W4. So 4 words can be, 4 words are there, right? W1, W2, W3 and W4. And we are identifying the W5, right? So we can say the all combination of capital P, that is a probability of all words together, right? So that is how the formula can be there to just segregate this all words together. That also can be the I have written the probability of capital P of capital W. So that can be the probability of W of n on W1, W2, so on Wn. But how do we calculate that? So that is going to be answered by the chain rule of probability. That is actually based on the Bayes theorem. So how it is going to be possible? The probability of A given B is equal to probability of A comma B divided by probability of B. That is a formula. If I will just take this here, that is a chain formula. If I'll take that here, probability of A comma B is equal to probability of A given B into probability of B. So that can be the chain rule of this probability. Right? These things we have to use here in the n-gram language model. Now generalizing this particular equation, we will get this P P of x1 to xn is equal to P of x1, P of x2 given x1, P of x3 given x1 comma x2, so on P of xn given x1 to xn. So simplifying this ever formula again, that is going to give the Markov assumptions. Markov assumption. So that is going to give us P of Wi given W1 to Wi minus 1. That is equal to probability of Wi given Wi minus k to Wi minus 1. So that is a Markov assumption that will be used in this particular language model based on n-grams. So for n-grams, for you, suppose unigrams, that same formula will be going to be applied. How? Let's see. So probability of W1, W2 to Wn can be equal to summation of probability of Wi, probability of Wi together. Same for bigram also. Now we can calculate this probability of the next word given on the previous word of words in a bigram model. How? Let's just expand that formula. We will use the following formula. So probability of Wn given Wn minus 1 is equal to count of Wn minus 1 and Wn, that divided by count of Wn minus 1. Count of Wn minus 1. So where we can see the P of Wn given Wn minus 1 is the probability of the n word given on the previous word, and the count of Wn minus 1 comma Wn is the count of the bigram model, that is Wn minus 1 and Wn in the text. The count of Wn minus 1, that is a count of the previous word in the text. So this is how we can just simplify that particular formula also. For example, let's say we have the sentence, the cat sat on the mat, right? So that is a famous example. So if we are applying a bigram model on this particular sentence, we would calculate the probability of each word based on the previous word. Let's see how we will do. So we will do like this. Probability of the given start is going to give 1. That is assuming start is a special token that is going to indicate the start of a sentence, right? So that we will use a 1. Then again, if we will use probability of cat given the is 1. So only one time it has been occurred. That's why 1. Again, the probability of sat given cat is 1. Probability of on given sat 1. Probability of the given on 1. Probability of mat given the that is 0.5. Means it is assuming that the is going to appear in the sentence twice. So here also and here also. That's why if that will be used here, right here. So if the one word has been used 2 times, so that probability will be half of that. So that's why 0.5. So like that we can just identify the different probability value also. So probability of each word given the previous word can be used to generate new sentences. We can evaluate the likelihood of a given sentence. So that's how we have get the different probability values out of that. The trigram model is similar to the bigram model, but it is going to calculate the probability of each word based on the previous 2 words. So let's see how we will do. Just to simplify that. So to calculate the probability of the next word given the previous 2 words in a trigram model, we use the following formula. So probability of Wn word given Wn minus 2 and Wn minus 1. So previous 2 words, and that is going to be equal to count of W of n minus 2 comma W of n minus 1 comma Wn divided by count of Wn minus 2 comma Wn minus 1. This is how we can just get the likelihood of this particular we can say formula probability. So where let's see again, where the probability of Wn given Wn minus 2 and Wn minus 1 is the probability of the nth word given in the previous 2 words, and count of that particular wn minus 2 and wn minus 1, and wn is the count of the trigrams. There are 3 trigrams. This is first, second and third, right? And the the count of wn minus 2 comma wn minus 1 is nothing but the count of the previous 2 words in the text. For example, let's say we have the sentence, I love to eat pizza. That is one sentence. So how many n-grams are there? 1, 2, 3, 4, 5. Right. So in this, if we are applying a trigram model, we would calculate the probability of each word given previous 2 words. So let's see how we will get the likelihood. So probability of I given start, comma start. So that is only one time it has occurred. Probability of love given start, comma I, that is 0 time occur. That is not there. Love given start I. Again, if I'll discuss probability of 2 given I love, one time it has occurred. Probability of eat given love to, one time it has occurred. Probability of pizza given to eat, one time it has occurred. So likewise that if we'll apply the trigram model, we can just identify the likelihood of this particular, we can say probability also. What is the count of probability? Again, the probability of each word given the previous 2 words can be used to generate the new sentences, evaluating the likelihood of the particular given sentence. So we can say the trigram models may be less accurate than bigram models because they require more context to calculate the probability of each word. So likewise that also, if we are using the 4-gram model, we are using the 5-gram model, the probability of that, the particular, we can say accuracy of the particular model can be just less of the when we are using the bigram model, just compared to the bigram model or unigram model. This is how it works. Consider an example of sentence for modeling. I love reading history books and watching documentary. That is a sentence. In 1 gram of unigram, there is 1 word sequence. As for the above sentence, in 1 gram, it can be all the different words can be the grams for this, n grams for this. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 1 grams are there. In 2 gram are the bigram, that is a 2 word sequence, that is I love reading history books, like that. So there can be the other possibility. In the 3 gram are the trigram, there are the 3 words sequences, I love reading history books and watching documentary. So there are 3 possibility of the n grams here. The illustration we will see how that works actually n-gram modeling. That is for whenever we are taking the n is equal to 1, n is equal to 2, n is equal to 3 and so on. So it is given by this figure. So if we are taking the n is equal to 1 in the sentence, this is a sentence. So unigrams can be there. This is a sentence. So 4, right? If we are taking the n is equal to 2, so the on the particular sentence, so bigrams can be there, 3 bigrams. 3 by. If I am taking the n is equal to 3, so this is a 1 and is a sentence 2. So there are 2 n grams are there. So that is how the different models will work to combine the different 2 words together. For n minus 1 words, the n-gram modeling predict the most occurred words that can follow the sequence, right? So the model is the probabilistic language model, which is trained on the collection of the text. This model is actually useful in applications, speech recognition, machine learning and machine translation. A simple model has some limitations also that can be improved by the smoothing techniques, interpolation techniques, back-off techniques. So these are going to give the solution for that. So the n-gram language model is about finding the probability distribution over the sequence of the word. That was all about today's topic. That was n-gram. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.